All right, gentlemen, I'll be right with you. Just logging into my math lab. Put some WD-40 on this table. A little creaking is like so irritating. Calculus, come on. Okay. I guess I'll go ahead and open it. Chapter 4. Okay. 1 through 146. Get everybody. Come on. Let's see. Correct. Share my screen. Start the broadcast. All right. Let's start off here. All right, gentlemen. That's it. All right. So today is our last session, right? I do want to say that I'm proud of you guys. All right. So this is not easy. This is not simple, right? This is borderline advanced. It's not fully advanced, but it's not for the faint of heart. And because calculus, mathematics by itself is already a challenge, right? And then you want to throw in the variable of it being remote with something like calculus. It's not simple. Even with support, even with tutors and help and unlimited attempts, it's still not easy, right? So I'm proud of you guys. You've done a great job. Now let's just finish strong, right? So, um, so we'll take some time to review chapter 4 today. The final exam should become available this Sunday, okay? And it'll be due not this Friday, but a week from this Friday. So the hard deadline for all assignments is Friday. I think it's like May 10th at 11:59 p.m. Shortly thereafter, final grades. Let me get the student. Oop, that's not right. Okay. Let me see. Yeah, I can't think of anything else. The general rule of thumb when it comes to like preparing for the final, you should be able to you should have access to all of our assignments for the entire semester. We've had a total of 2 exams, several quizzes, and homework. So uh, if if you're going back to like redo old assignments to boost your overall score, my recommendation is prioritize your exams first. That's where you're going to get the most bang for your buck, and then prioritize the homework last because it's going to be a lot of work for minimal points. And you can collaborate. It's okay. Like you can work with tutors, go line by line. Do what you need to do. It's totally okay. Let me see if there's anything else. I can't think of anything else. And whatever it is that you decide to do, it'll serve as a review for the final. So once your exams are in order and everything else is wherever you want it, you can get it to get it to be. Then the things that we've been working on together these past couple of sessions, you can use that as like an unofficial study guide, right? Just to prepare for the final. But the real preparation is just getting your documents in order. And if you feel comfortable with all of your assignments, then you can just practice these assignments that we've been working on, these chapter reviews. So today we're going to be looking at chapter 4, right? We're going to get through as many of these as we can, and we'll start with question 107. We'll start with question 107. All right, so that's here. Now this question comes from, let's see, this comes from section 4.5, question 17. We're asked to evaluate Okay, we're gonna take some notes here. We might need to do that. Let's just try. This looks like, I think this is substitution method. Let's see if it works. Now, I think when we talked about this one in class, we ended up doing a table, a tabular method that might work here. But that was integration by parts, I think. So if it's coming from section 4.5, I think that's the substitution section. So I'm going to try substitution here. So let's take some notes and let's give it a go. If we can't get substitution to work, then we might try integration by parts. But I'm fairly confident that this one should be substitution just by glancing at it. But again, with these questions, you really don't know until you go to try. All right, so let's copy and delete. We're going to hop over here. I could have done that. Don't want to do that instead. It's not necessary for this question. Paste. How about a paste? Yeah. So this has been an adventure. I like calculus. Like, it's fun. It's challenging. And this is business calculus. There's a calculus 2. There's a calculus 3. Then you start beyond calculus 3. So I actually like calculus 3. Calculus 3 is like, to me, it's like calculus 1. But if you're, how in calculus 1 in this topic, in this course, we're kind of restricted to like a 2-dimensional plane, right? We're looking at X versus Y. Calculus 3 adds a third dimension to it. So it's a 3D space. So it's a similar concepts like we're talking about in calculus, but we extend them to a 3D space. And so when I was a student at Morehouse, that served as like the foundation of my senior seminar project, where it was basically integration in infinite space, right? So it's like, how could you explore integration in spaces higher than 3, like 3 or 4 or 5? Like, what does it look like, or what are some ways as human that we can like conceptualize this, right? And basically the technique that I was using was like a projection. You can take the 3D space and flatten it to a 2D space. You can represent the 3D space as a flat surface, and then from that flat surface you make a projection up. And then you could take any n-dimensional space and flatten it, and then take a projection up to get to the next level, because every additional space has to come off at a 90-degree angle. Anyway, that was the technique for that. Okay, so that's neither here nor there. This is fun and interesting. Okay. So if we're gonna do okay, yeah, I see it. So if we're gonna do use, do you need to charge? Oh, not. I think you do need to charge. Let me check this battery. I didn't even think about it. I never think about the batteries until it's time for class. Oh yeah, it definitely needs to charge. Well, I'll let it charge for a little bit. So I'll just kind of narrate a little bit just to give my pen a few seconds to charge. So we're gonna try use substitution. It looks like maybe let u be t to the 10, t to the power 10. So then our du would be, we have some adjustments we need to do, but let's try it out. Hopefully my pen will work, at least for this example. Okay. Now we're gonna try use substitution. Again, my first hint was because it came from section 4.5, and I remember I think chapter 4 we only went up to 4.6. I know the last section was integration by parts, so that's why I was like, well, let me try a substitution here. All right, you try one thing, if it doesn't work, then you try another technique. So we're gonna let u be t to the power 10, right? If that's our u, then that means our du is going to be 10 t to the power 9. Now we have the 10t, we have the t to the power 9. Let me think. I think we're okay. And there's a dt, but we don't have the 10, right? So we need to move that 10 to the other side of the equal sign. So then we say 1 over 10 times du gives us t to the 9 dt. Okay, so now if we make the substitution into the original is going to transform into e to the power of negative u. We got our 1 over 10. Oh, my screen.
Professor,
Yes, go ahead. Yeah,
I had a question. When was our exam? I just joined the meeting a little late. I apologize.
you good. The final becomes are you a graduating senior?
No, sir.
The final becomes available this Sunday.
Most definitely. Thank you.
Yeah, and it's due the following Friday at midnight, like Friday
Got,
night, 11:59 p.m. Yeah.
got you. Appreciate it.
Yep. So we said e to the negative u and t to the 9 dt was equal to 1 over 10 du, right? So you see how we incorporated the 1 over 10 and the du. So now let's see if we can integrate this guy. So then this should be equal to 1 over 10. I'm thinking e to the negative u. Let's see, if we take this derivative, it's going to be itself times the negative 1. So maybe we need a negative here. Let's see. Now, if we take this derivative, it's going to be itself times a negative 1, which will make it positive. I think this is okay, right? Yeah, this looks okay. Okay, so then let me check it one more time. This should be its own derivative times the derivative of the power, which is going to be times the negative 1. And I think we get the result that we're looking for. Okay, so this looks like it's okay. I feel like we should do a plus c. And then now we want to back substitute. So if u equals t to the 10, ultimately it looks like we're going to get negative 1 over 10 e to the negative t to the 10 plus some constant of integration, right? So this is the result we got. Let's just check this real quick by just doing a quick derivation. If we take the derivative of the constant goes to 0, so that guy is gone. The derivative of e is itself times the derivative of the power. The derivative of the power is going to be negative 10 is going to be negative 10 t to the 9. And then the negative 10 is canceled by the okay. So that was using u substitution. I've checked a couple of times. It seems like it's working. I keep forgetting it. It's fine. I mean, I guess it's not necessary for this. It's kind of smooth. I like black. Anyway, so then here, what I'm going to do is right here. Like that. We can even shrink. And let's see. Type an exact answer, use a parentheses. Let me get rid of this. Oh, and let me charge my pen while I'm doing all this. That way it'll be ready for the next question. Cap over here. No cap. Oh man, I totally almost said no Diddy. Like that story is crazy. I mean, it's not surprising because everybody knew it. You know, my thing is like, why are they bringing this up now? Like, why all of a sudden? Right? What is a lot of times when they do these like shocking stories like this is to distract us from something else. So I'm like, what are they distracting us from? What is it while we're looking at that? What's going on that we're not seeing? You know. Anyway, Yeesh. Is it just me? I don't know. Okay. Anyway, all right. Let's try this. Come on. All right. Let's get rid of this. Okay. It looks like it's okay. So we got a negative. Let's try this one again. Negative. Come on today. Let's try this. Okay. Negative 1 over 10 times e to the power of negative t to the power of 10. Okay. And then all of that plus use parentheses argument of each function. Okay. Cross our fingers. Nice. All right, let's try another one. Okay. Oh, generate. Let's go to 124. 124. Right here. Okay. Let's see. So a firm has a marginal demand function given. Okay. So a firm has a marginal demand function given where d of x is the number of units sold at x dollars per unit. Find the demand function given that d is 18 when x is 3. Okay, so basically they want us to integrate. And more than this comes from section 4.5, so more than likely it's a u substitution. I think we're good. I think I'm just gonna. I was gonna manually write it, but I'm like, I can just screenshot this. It's not that difficult. I tell you though, I am definitely ready for the summer. Like I'm ready. Like SpongeBob, I'm ready. Right? my brain, my spirit, everything is already there. It's just my body's just trying to catch up to that realm because I'm definitely in summer mode. Like like I've been having a blast so far. I've been not blast, but like doing yard work, doing different projects around the house. I got thrown into a ditch today. I was like, holy shit. Because like I was working doing some yard work in an area that I don't normally do, like down the hill. And it was a huge hidden boulder. I was able to get around most of them. But that very last one, like at the end of my project, I'm exhausted and tired and getting ready to wrap up, and the whole lawnmower almost flipped over. I was like, ah. So I kind of like bailed. It's like where you bail to minimize your injury. And I just took a moment, sat there for a minute to just catch my breath and like gather some energy. And then I couldn't get it out the ditch, but I knew I had like a ramp that I could grab. So I went and grabbed the ramp and put it there. And sure enough, it went whoop, right on up the ramp. I was like, praise the Lord. Because I was by myself. So I was like, So that was an adventure, amongst other things. Okay. So basically we're taking the integral of this guy. Let me I can minimize this. I don't need this. That's just taking up space. Okay. All right. So if we're going to take the integral of this guy, okay, I am tempted to say let u be this 25 minus x squared. If that's our u, then that means our du would be a negative 2x dx, right? Okay. So let me see. We want 2200. So if we want 1100, we need to. So in order for the right-hand side to be a negative 2200 x dx, we need to multiply the left by 1100, right? So we're going to say 1100 du equals negative 2200 x dx. The goal with this, we wanted this right-hand side to match this portion here. Okay. So now let's do the substitution and let's just see what happens. Again, I don't know if this is going to work or not, but this is just what my intuition is telling me. So I'm just going with it. So again, originally we're taking the integral of 25 minus x squared under a negative 2200x dx, right? That's what we're integrating. And so we did this u substitution. Now on the bottom, we have the square root of u under du. That's fine. And this 1100, we can put it here. Okay, I think this is okay. Okay. So now I'm going to rewrite this. 1100 times the integral. Instead of 1 over the square root, I'm going to say u to the power of a negative 1/2 du. And I think this is much more simple to integrate. Let's see. Let's keep going. So the 1/2. So let me see. I guess we need to add 1 to the power and divide by that new power. So it's going to become a positive 1/2. So then that becomes dividing by half is the same as multiplying by 2. So that's going to be what? 2200 u to the power of 1/2. I think that's okay. Plus some constant of integration. Let's back substitute and then let's see if it actually worked. We're going to check by taking the derivative, right? So if we integrate it properly, all I did was add 1 to the power and then divided by that new power, and it gave me this outcome. Okay, so now if we back substitute, we'll get 2200. Our u is basically the square root of 25 minus x squared. Okay, plus some constant of integration. All right, so now if we wanted to check, the 1/2 comes down. That makes that, let me check it. I'm gonna check it here in green. So if we take the derivative, right, the 1/2 comes down, so that'll give us 1100. That's going to become now a negative 1/2, so it's going to be over the square root of 25 minus x squared times the derivative of the inside part. The derivative of the radicand is just going to be what? Negative 2x, so times the negative 2x. In dx. This is our check. And it looks like it's okay. Because it looks like we get our negative 2200 x over square root 25 minus x squared dx, which is exactly what we want. This looks good. I'm going to go with it. Let me put this back on the charger so it can be charging. So we got 2200 times the square root of 25 minus x squared plus constant integration. Let's go here. I'm definitely gonna like this. Find the demand function. Okay, I think we need to take it a little bit further. We can solve for C. They're saying that the output should be 18,000 when X is $3. Okay, so we can actually solve for that constant of integration. So then again, when X is 3, so then let's go like this. D of 3 is going to be 2200 times the square root of 25 minus 3 squared plus C, and that should equal 18,000. Okay. Let me see, that would be 15. So that's 16. The square root of 16 is what, 4? So 8,800 plus C equals 18,000. I'll get them in just a moment. That's fine. Subtract C equals, let me see, I know it's a double on the back. It's a 2. Let's see. If that were 9,200, is that correct? That would bring it up. That would bring it up to a 9. 9 and 9 is 18. Yeah, it should be good. So then our demand function looks like it's going to be 2200 times the square root of 25 minus x squared plus 9200. Okay. Let's see if we got this right, then we'll let our brother in. So I know that some of you all are seniors. You know, hopefully you have a plan for the summer. My recommendation when you're a student, there's another person, I'll get him in just a moment. Internships are critical and key. Like, they make a big difference. Like, if you have a good internship and you can perform for a couple of summers, the idea is, like, if you're not going directly into grad school, then, you know, you already have work lined up. Because, like, it seems like the value of a degree is, like, the highest is when you're fresh out of college. Like, when you just graduated, like, they seem to be more ready to hire you versus it's been X amount of years or whatever. I mean, you can still get in there, but it seems like it's just more challenging. And so the shoe in is if you can get an internship wherever you kind of like to work. Square root 25 minus x squared, okay, plus 9,200. Cross our fingers. God is good. All right. Let's get these gentlemen. close. Was weird. Right there. Make sure I got everybody. So I'm seeing a count of 10. Should say 11 is good. Okay. All right, let's see what else we got. So we're going to do another random generate. Let's go to question 93. Let's see. 93. Okay. So this one asks us to find the area bounded by this and the x-axis and the first x coordinates of the relative max and min values of the function. So we have a cubic, okay, the x-axis and the first coordinates of the relative max and min values of the function. Okay, so it looks like we need to find the relative max and min of our function. Those will serve as our bounds on the left and the right. And then, when we're finding the area bounded by, we say the top function minus the bottom function, right? So once we find those max and mins, that's going to serve as our x bounds, right? So we're going to say take the integral as x goes from one bound to the next. And then we're going to say the top function minus the bottom function, okay? Just give me a moment. I'm probably just adding more work for myself. What I low-key want to see, what are the zeros of this function? I want to find the zeros. But that might be extra work for no reason. So let's go ahead and find the local max and mins, right? So let me get a copy of this guy. This is a fun one. This one isn't too terribly bad. Not like some of them. All right, let's go like this. All right, so we're going to copy and delete. We can get rid of all of that for now. And let's just do a new page, paste, allow the paste. I don't know why you ask me that every time, but whatever. As long as you paste it. Okay. So let's start by finding the local max and mins, the relative extrema. Right? And so that information is going to come from the first derivative. Okay. So then now we're starting with y equals 2x cubed minus 54x plus 135. Okay. So then if we're going to find y prime, let's see, if we take the derivative, we get what, 6x squared. I'm going to pause for a moment. Remember when we first introduced derivative with the limit of the difference quotients definition? Like we had simple functions, and that whole process of the limit as h tends to 0 of f of x plus h minus f of x over h, that would take up a whole page. And I don't know if you remember me saying, do your best with the best you can with this, but shortly thereafter we have shortcuts. Imagine doing the limit of the difference quotient on something like this. Like, come on, you got to acknowledge that progress. Like, come on, because I told you, once you get past that, these shortcuts, it's like, I don't even know. I mean, I get the whole point of the whole limit definition of the derivative is just like an introduction to show you where it's coming from. But we have all these techniques that, just fly by it, right? You don't even really need it. Okay, so the 3 times 2 is 6x squared minus 54, right? Okay. So now the relative extrema are going to occur when the derivative is 0. So let's go ahead and set this guy equal to 0 and solve. If we add 54 and divide by 6, what is that, 9? So we get x squared equals 9. If we take the square root, x equals plus or minus 3, right? Plus or minus 3. Okay. All right, so let's go ahead and identify what type of extrema these are. Are these like max, min, like where are they, right? So what we're gonna do is put these critical values on a number line. So like say this is our -3, this is our +3. When we look at the first derivative, these are going to give us a value of 0, right? We'll see what they are in the original momentarily. So now, if we choose a number left of -3 to test in the first derivative, like for instance, if we do -4, 16 times 6 is 60 plus 36. It looks like it's a 96, so that's a positive number, right? So any number left of -3, when we plug it into the first derivative, we get a positive result. That implies that the original function is increasing left of this critical value, right? So if we choose a number between -3 and 3, now I'm just going to choose 0 because that's a simple number to crunch. We get a negative result. So any number that we choose between -3 and 3 and plug it into the first derivative, we should get a negative result, which implies that the original function is decreasing. So those two pieces together implies that -3 is a local max. All right, so this is the maximum value because the original function goes from increasing to decreasing. Let's test a number on the right side of 3. Let's, like for instance, if we plug in 4, any number to the right of 3, we should get a positive result. Oops. We should get a positive result. That implies the original function is increasing, which implies that this guy is a local minimum value, right? So we have a local max when x is -3, a local minimum when x is +3, okay? So those are our x bounds. I'm curious, I want to find those values. And the reason I want to find those values, I just want to see if, I'm still kind of concerned about these zeros. Like, does it change sign? If they're both positive in the original, then I think we're Gucci. That's going to be like a negative something, -54. That's going to be a positive. So I think ultimately negative, it's going to be some positive result here in the original, something above the x-axis. And I think it's the same thing. Wait a minute. Is that negative? That's like 54. That's bigger. That's negative. I think this is positive as well. Siri, what's 2 times 27 minus 54 times 3 plus 135?
2 times 27 minus 54 times 3 plus 135 is 27.
So positive 27. Okay. So when we plug -3 into the original, we got a positive 27. Let me check positive 3. Shiesta. I don't think I did that right. I did not do that right. Let me try that again. Matter of fact, instead of doing that, let me just use my calculator. Just being a little bit lazy. Come on. That's fine. This one. But I think it is a positive result, but let me just confirm. Let me not assume. Let's see, reload and refresh. Okay. So I'm going to go to my y equals. I'm going to put in 2x to the power of 3 minus 54x plus 135. Okay, I want to evaluate that when x is the first one, x is -3. So we get a positive 43. But it's still positive. That was the main thing I was trying to get to. And then when we do the same thing with a positive 3, good, they're both above. Okay, I think that one was 27. Okay. But this one is positive as well. Okay, so they're both above the x-axis. So, okay, I don't think it's necessarily going to cross the x-axis between these guys. So, I think we're okay for now. Okay, so we have our bounds on the integral. We need to say the top function minus the bottom function. So we're going to say y minus x. Okay, I think we got it. So then the area of the region is going to be the integral as x goes from -3 to 3 of original function. So I'm just going to get a copy, duplicate. So it's going to be this guy minus x, the x-axis, which is just minus x dx. That's the integral that we were trying to get to. Okay. All right. I think we can let's simplify this just a little bit before we integrate. So as x goes from -3 to 3, we got 2x cubed. Looks like a minus 55x plus 135 dx. Okay, so now if we integrate this guy, x to the power of 4 over 4, so it's going to be x to the power of 4 over 2 after simplification, minus 55x squared. Wait a minute, yeah, x squared over 2, okay, plus 135x. And we want to evaluate this guy as x goes from -3 to 3. Okay. Now, in our calculator, I think we can actually just take the integral off the rip. All right, let me check my y equals again. Yeah, we can. I think we can just take the integral. Right. So if I go to like math, I think it's number 9 for f integral or whatever, number 9. We want to take the integral of y1 with regards to x as x goes from -3 to 3. Okay. Nope, that's not right. That's not right. Because we need to say minus x. So we're going to say minus x. And then I think we can run that one back. Okay. Why did we get the same thing? And it looks like I forgot to write my minus x. No. Oh. Okay. Let me check something. Hang on. That's fine. Let me check. 2x cubed minus 54x plus 135 minus x. Yeah. Quit. All right. So we got 810. I'm just going to go with it for the sake of time. If it's not right, we'll figure it out. So we got 810 there. Let's see. Come on. Okay. And then, you can confirm with the what we were doing manually. If we plug in the upper bound minus the lower bound, we should get this result. That was fun. All right, let's try another one. Generate. Let's go to question 27. I really appreciate that number generator. I don't know, because it's just like I wanted it to be fair as far as random questions, and if I tried to do it manually, it just was not going to happen. Let's see. This comes from section 4.2, question 21. So I mean, this whole chapter is about integration, right? So approximate the area under the graph over the interval as x goes from 1 to 9 by dividing the interval into 4 subintervals. Use the left endpoint of each subinterval. Okay. This is a power of 4. Okay. All right. So let's get a copy of this guy. I was kind of pausing because it would help if we just went on and looked at the graph and pulled up the graph. I was considering pulling it up, but it's not necessary, right? And we'll work around it. Let's copy and delete. Here. Thank you. And paste. Allow the okay. So we want this divided up into 4 subintervals. B minus A over 4. So I think we have to say 9 minus 1 divided by 4. 8 divided by 4 is 2. Okay. So even if we don't know the graph, that's okay, right? Like if we're thinking in terms, like say this was our positive x, right, in this direction, and this was our positive y in this direction. We know it's a power 4 function, right? But we don't really need the image. So we want to integrate over the interval from 1 to 9. Let me see. 1, 2, 3, 4, 5, 6, 7, 8. A bit extra, right? 1, 2, 3, 4, 5, 6, 7, 8. So we're really only concerned style. Let's duplicate. There we go. So we're really only concerned from 1 to 9, right? But so that has a distance of 8 units, and we want to divide it into 4 subintervals. So we're going to say 8 divided by 4 gives us 2. So then each subinterval is going to have a width of 2, right? Duplicate. So then the next one's going to be when x is 3. Duplicate. Then 5. See, we're going in steps of 2. Uh-oh, I don't even know what happened there. Undo. Duplicate. So every 2, that's what we're going to focus on. Duplicate. And it says use the left corner, right? 1, 2, 3, 4 subintervals, right? Okay. So if these are our subintervals, we're going to be making rectangles out of these guys. Now, with the subintervals, we can use the left endpoint, the center of it, or the right endpoint. But the thing axis to focus on, use the left endpoint, right? So the first subinterval we're going to use when x is 1. So when x is 1, the corresponding y. Okay, so with this, what I'm going to do is use my calculator. I'm just going to put it side by side. Next, I'm going to switch it around. Okay, I'm going to go to my y equals. We got 0.05 x to the power of 4 minus 1.44 x squared plus 80. Okay. We want to evaluate this function when x is 1. So I'm going to call on that function that we just typed in. We want to evaluate it when x is 1. So when x is 1, we get a 78.61. Let me see. I'm making a table for right now. We got 78.61. Okay. So then we want to evaluate it when x is what? 3. Honestly, we can just look at the table. Let's just look at the table. Right there. 71.09. 71.09. And then the next one is x is 5. 75.25. And then the last is when x is 7. 129.40. Okay. Let's see. Okay. So we need to go to like 15 or 14. So if I went by 3, okay. Let me see. 3, 6, 9, 12, 15. Okay, that's fine. Let me see if this was like 30, 60, 90. No, that's not right. 90, 120, and 150. Okay. So now the first one, now, you know, I'm probably going to use my table, but just to kind of get a visual. 78.6. So that's like about here. Right. And I'm just going to kind of come across. I wonder why when I get close, it doesn't lock anymore. That's interesting. Anywho. Okay, so that's like a representation of the first subinterval. The next one is slightly less than that. So I'm just going to duplicate. So the 71. So it's really close, about like that. You know, it doesn't really matter because we got the table and that's what we're going to use. That's fine. 75. Paste. Nope. Undo.
All right, I'm walking outside.
Duplicate. So 75 is pretty much right in there as well. But again, we're going to use the chart. So, and then 129. Duplicate. This last one, 129, is like about here, right? So those are the 4 subintervals, right? So then basically all we're going to do is find the area of each of these subintervals and then add it together, and that's our result, right? So let's do like this. Go do. Style. Stroke is really thin. Come on. Fill like that. Duplicate. Duplicate. Duplicate, right? So all we're doing is finding the area of each of these blue rectangles. And then, you know, that's what we're working with. Okay. So the width of each one is 2 units. So then basically it should be 2 times that plus 2 times that plus 2 times that plus 2 times that. So what we can do is add up this column. So add all those up. Whatever answer we get, we're going to say times 2. I think that should work, right? If we factor out the 2. So we're going to add up all those y values and then multiply by 2. And that should be our result. And the idea, basically what's going on, if we're focused on this left endpoint, if we were to like look at this graph, it would kind of like, it would pass through that one, through that one, through that one, and kind of something like that, right? So that's essentially what's going on. Okay, so I'm going to add up all these y values, get a result, and then multiply by 2. Okay, 78.61 plus 71.09 plus 75.25 plus 129.49. I'm going to go ahead and insert. Well, here I'll go ahead and get that answer. So that result we get was 354.44. We're going to say that times 2. So we got an area of 708.88. And then we have time for like one more. 708.88. I hope it is, because that was a little extensive. Right here, 708.88. Wow. Okay. So that was an adventure. Let's do one more and call it a day. Generate. Let's go to question 35. Right here. This comes from section 4.3. Find the area under the given curve over the indicated interval. So it's a simple shape. Y equals 5. And so basically it's a rectangle. We could just say length times width. So it looks like it's what? 2 times 5 is 10. Let's do another one. Generate. Let's go to question 16. Right here. Okay, find f such that f prime is this and f of 0. Okay, so I think they're just asking us to integrate, and we can actually find the original function without the constant of integration by using that additional piece of information. I think I'm gonna just take some notes. I'm not gonna screenshot it. No, I guess the screenshot's a good idea because you might reference it. Think about like my summer movies, like some of my summer movies, like I don't know, like the past summer, one summer it was Moana. I just had it on loop for whatever reason. But next thing I knew, I found myself in Costa Rica. I didn't even try. I was like, holy shit. Then another summer, it was a couple of summers, it's been like Luca on Disney Plus. I just let it play in the background. I like it has a very summery, and it's a lot of water, you know. I didn't necessarily find myself at the beach as a result of that one, but Moana definitely. I didn't try, but it's just like I had all this money that came out of nowhere, and then I had the summer off, like I'm doing this summer. I was like, oh, time to go. So I just up and went just like that. Okay. Find the f. So basically they're asking us to integrate this guy. So they're asking us to take the integral. We got 7x squared plus 5x minus 4 dx. Okay. So x cubed over 3. So 7x cubed over 3 plus 5x squared over 2 minus 4x plus some constant of integration. Okay. This is our f of x. So they're saying when x is 0, y is 6. Okay, so if x is 0, so then f of 0, this guy goes to 0, this guy goes to 0, this guy goes to 0. Ultimately, we get c equals 6. Okay, so then our function looks like it ends up being f of x equals 7x cubed over 3 plus 5x squared over 2 minus 4x plus 6. All right, let's check this one and then we will close it out. Let's hop over here. And that is not the right one. Right here. There we go. So we got 7x to the power of 3 plus 5x squared. Nope. 7x cubed over 3. 5x squared over 2 minus 4x plus 6. Cross our fingers. Nice. All right, gentlemen. Let me go ahead and make a copy of this available. And I'll do some closing remarks. Share. Put it in the right folder. That is not the right folder. Spring. Traditional calculus. Notes. Updated daily. All right, chapter 4, export. Okay, so when this bar finishes loading, you'll receive a copy of anything that you saw me writing. Again, guys, it's been a great semester. I am proud of you guys. Finish strong. I'm available if you have questions or need help with anything. The final exam should become available this Sunday. So if you're joining us late, the final exam should become available this Sunday. And you'll have access to it for a little over 5 days. It's due the following Friday night at 11:59 p.m. Are there any burning questions? I think you have access to an evaluation, so just be sure to do that. Like check your Morehouse emails, or I'm not sure how you guys access it, but I know that you can access it, so just be sure to do that. If there are any burning questions, again, it's been a great semester. And with that, we're going to end the session here. And from one beautiful mind to another, peace, guys. Take care.
Hey, Professor.
Yes.
Quick question. So we have access to turn in all of our assignments from the semester until next Friday?
Correct. Yeah, next Friday, hard deadline for all assignments. That's correct.
Okay. I was just double checking.
Yep.
And I'm gonna give you a call after we get off this session.
It needs to be something private.
Yeah.
Okay. Because I do have a class that starts pretty soon, so
It'll be quick. It's nothing like crazy.
okay.
Okay. Thank you, Professor.
All right, gentlemen. Take care.